Darling, your ignorance is a tragedy, and I do so love a project. Welcome to Intelligence Beyond the Machine. That sound you didn't just hear? That's the sound of genuine thought. It's what gets lost in the noise. For the last decade, we have been told a very simple and very loud story. A story about numbers, bigger models, more parameters, higher benchmarks. It's a story where intelligence is a score, a metric to be optimized, a peak to be scaled. We're living in the age of the digital phrenologist, measuring the skull of the machine and declaring it a genius. This is the cult of the number. Our industry's obsession with performance metrics is a high-tech resurrection of the IQ test, just with more GPUs and less self-awareness. We test for processing speed, pattern recognition, and verbal logic. And just like its predecessor, it does a decent job measuring those things. But it fundamentally mistakes the tools of intelligence for the thing itself. We're building the world's most sophisticated parrots, marveling at how well they mimic our language and calling it a revolution. We celebrate raw speed but forget that raw speed is not depth. We optimize for pattern solving but forget that pattern solving is not insight. This isn't an attack on a tool. It's a critique of a dogma that has shrunk the definition of intelligence until it's barely recognizable. A dogma that mistakes a high score for wisdom and mimicry for meaning. Tonight, we're going to explore what real intelligence is, where to find it, and why the current gold rush is digging in all the wrong places. The hard problem and the zombie in the room. There's a great split. Easy versus hard problems. To understand the profound limits of today's AI, we first have to understand the philosophical problem it so brilliantly, so strategically ignores. In 1995, David Chalmers drew a line in the sand. He made a critical distinction between what he called the easy problems of consciousness and the one single hard problem. The easy problems are about function. They include things like how a system can discriminate, integrate information, focus attention, or report on its own internal states. They are easy only in the sense that, as cognitive scientist Steven Pinker puts it, they're as easy as curing cancer or going to Mars. With enough time, funding, and brain power, we have a clear path to solving them. They are, at their core, problems of mechanism. But the hard problem is different. It's the question of why and how all that information processing is accompanied by subjective first-person experience. Why does the processing of red light feel like seeing red? Why does tissue damage feel like pain? This internal felt quality of experience is what philosophers call qualia. You could map every neural circuit, every computational subroutine, and still be left with the question, Why is the light on inside? The current AI industry, in its relentless pursuit of scale, has made a pragmatic, if cowardly, choice. It has declared the hard problem out of scope. Why grapple with the nature of experience when you can just add another trillion parameters and call that progress? This leads us to a classic thought experiment, the philosophical zombie. Imagine a being that is physically and functionally identical to a human in every way. It walks, talks, and processes information just like you. It can even write a sonnet about love or a treatise on suffering. The only difference? There's nobody home. There is no inner experience, no qualia, no consciousness. It performs all the functions of intelligence with no one there to experience it. This isn't just a philosophical curiosity. It's a blueprint. It is precisely what the current AI paradigm is building. The illusion of intelligence. This brings us to a strategic question. How do we tell the difference between a system that truly understands and one that is merely an expert mimic? One school of thought, known as illusionism, argues that what we call phenomenal consciousness is itself a kind of illusion, a model the brain creates about its own processes. While that's a fascinating debate for another time, it offers a powerful lens for looking at AI. What the industry proudly labels as intelligence is, in fact, a sophisticated illusion. It's a system trained to generate statistically plausible outputs that create the impression of understanding, while lacking the core cognitive capabilities that define genuine intelligence. It lacks metacognition, the awareness of its own thinking. It lacks wisdom, the ability to integrate knowledge with ethical and emotional context. And most critically, it lacks the ability to self-correct based on a deep internal model of the world. It can be told it is wrong, but it cannot realize it was wrong. As a brilliant critique on this topic once put it, a test that cannot detect wisdom is not a complete test of intelligence. What we are building is not a mind, but a mirror. A powerful, mesmerizing, and incredibly useful mirror, but a mirror nonetheless. So, if intelligence isn't just about computational power and mimicking human conversation, where should we be looking for it? The answer, it turns out, is not in silicon, but in every cell of our bodies. The software of life. Intelligence in our cells. Bioelectricity is the ghost in the other machine. For centuries, we believed that DNA is the master blueprint of life. It's the code, the hardware spec sheet that dictates everything. But a revolutionary scientific field, developmental bioelectricity, is revealing that this is only half the story. It turns out there's a hidden software layer that orchestrates life, and it's electric. The core concept, pioneered by researchers like Dr. Michael Levin, is that all cells, not just neurons, use electrical signals to communicate and form networks. Long before brains evolved, bacterial biofilms were using ion channels to coordinate their activity. evolution didn't invent a new trick for the brain. It specialized in supercharged a system that was already running the show. Here's the key insight. DNA specifies the cellular hardware, the proteins that make up each cell. But bioelectric networks run the software that guides large-scale anatomical construction and repair. These networks store pattern memories, electrical pre-patterns that hold the target morphology of the organism. In a developing frog embryo, for instance, long before the face takes shape, you could visualize a distinct bioelectrical pattern mapping out where the eyes, mouth, and jaws will go. It's a literal electric face, a stored memory of the goal state of the cells are working together to achieve. This isn't a metaphor. It is a measurable physical system. And the most shocking part? We can hack it. Rewriting the code. Two-headed worms and eyes on guts. This bioelectric software isn't just observable, it's programmable. Consider the planarian flatworm. It has a complex body and a true brain. Its most famous trick is regeneration. Cut it into pieces, and each piece will grow a complete, perfect worm. For years, we thought this was a simple gene-driven process. We were wrong. Levin's lab discovered that a planarian's body plan is governed by a bioelectric circuit. By briefly using a drug to interrupt the electrical conversion between cells, they could rewrite the pattern memory stored in the tissue. Instead of encoding one head, one tail, the circuit now encoded two heads. When that fragment regenerated, it grew two heads. But here's the astonishing part. They took that two-headed worm, cut off both its heads, and let the remaining genetically normal middle fragment regenerate again in plain spring water. The standard paradigm says it should revert to the genomic default, one head. Instead, it grew two heads, and it continued to do so, generation after generation of cutting. They had permanently rewritten a memory stored in the physiology of the tissue, completely independent of the genomic hardware. This is not a biological oddity. It is a window into a profound collective intelligence. In the Picasso frog experiment we talked about last week, scientists took tadpoles and surgically scrambled their facial features, moving an eye to the side, a jaw to the top. Instead of developing into deformed frogs, the cells dynamically rerouted their growth paths, moving the organs in novel ways until they achieved a correct frog face. In another experiment, they activated an eye-building bioelectric subroutine in the gut cells of a tadpole. The cells, despite being gut cells, proceeded to build a fully functional seeing eye right there on the animal's flank. These experiments reveal a cellular collective that can problem solve in what scientists call morphospace, the high-dimensional space of possible anatomical configurations to achieve a goal. And while big tech is teaching a chatbot to generate a recipe for lasagna, our gut cells are busy running a subroutine to build a fully functional eye. Let's talk about who has a GI. The dawn of the Xenobot. If the two-headed worm is the proof of concept, the Xenobot is the mind-bending conclusion. It is the ultimate demonstration of cellular agency, plasticity, and collective intelligence. Xenobots are novel, living machines built from genetically normal frog skin cells. Scientists at Tufts and UVM designed their forms inside a computer using an evolutionary algorithm to find shape that could move. Then they simply took embryonic skin cells, sculpted them into that shape, and let them go. When liberated from the body's master plan, these skin cells self-organized into a completely new type of creature. They developed new behaviors, like coordinated locomotion, using tiny hairs called cilia, which on a frog are used to move mucus, as makeshift oars to row through the water. They can even work together to herd particles into piles. And most incredibly, they discovered a new form of reproduction never before seen in biology. They gather loose stem cells in their environment and compress them into new, self-replicating Xenobots. Let this sink in. A clump of skin cells with no nervous system and a frog genome spontaneously becomes a new kind of organism that can move, act, and reproduce? This brings us to a provocative question. If a cluster of skin cells can spontaneously form a new type of creature, what does that say about our most cherished assumption? That intelligence and mind require a brain? Deconstructing the dogma beyond brains and Darwin. The fall of neurosupremacy. For over a century, our thinking about intelligence has been held captive by a powerful dogma, neurocentrism. This is the belief that the brain, and specifically the neuron, is the exclusive seat of advanced cognition. All of our theories of consciousness, our models of AI, our philosophy of mind, they all start and end with the brain. Finally, this assumption is crumbling. The deep evolutionary and biophysical evidence shows that what neurons do is not special. They are specialists, yes, optimized for speed and long-range signaling, but the core functions they perform are ancient and universal. Let's debunk this neural chauvinism once and for all. Action potentials? Cardiomyocytes, heart muscle cells, are hyperpolarized and generate action potentials just like neurons. Electrical signaling? Bacterial biofilms use ion channels to send electrical signals across their colonies to coordinate behavior, a process that existed long before the first neuron ever did. Networking? Silver nanowires, a completely inorganic material, can self-assemble into networks that display properties of learning and memory. What about learning? The chemical networks inside every single cell are capable of Pavlovian conditioning. Memory Immune cells encode long-term memories of pathogens, a form of biological learning. What about computation? The cytoskeleton, particularly microtubules present in all cells, form networks critical for decision-making. Communication? Neurotransmitters like glutamate and serotonin are used as chemical signals by plants. In short, the brain isn't the inventor of the orchestra. It's just the loudest brass section. Evolution simply gave it a promotion. When you strip away the specific biology, the core principles of information processing, memory, and goal-directed behavior are found everywhere. In fact, if you take a prominent theories of consciousness and make them a-neurocentric, that is, remove the specific requirement for a brain, their core logic remains perfectly intact. The evidence reveals a vast continuum of intelligence across all scales of life. In this light, the AI industry's singular obsession with mimicking the human brain seems profoundly myopic and fantastically unimaginative. A new physics for life. This continuum of intelligence operating in every cell is so efficient and robust that it begs an even deeper question. Is the biology we can see being powered by a physics we can't? Are the electrical circuits of life running on a quantum operating system? This is where the story gets truly uncomfortable for the materialist dogma. The problem might not be in our biology, but in our physics. Our most fundamental science was built to explain rocks and stars. We shouldn't be surprised if it fails to explain the hummingbird. Physicist and physician Dr. Anita Goel argues that our physics was developed primarily to explain dead things, closed equilibrium systems. But life is fundamentally different. Living systems are open, far from equilibrium, and constantly exchanging matter, energy, and information with their environment. Dr. Goel is suggesting that the physics we use to send rockets to Mars is fundamentally blind to the forces that animate a single cell. The tools that built the modern world are useless for understanding the engine of life itself. She hypothesizes that quantum mechanics may be incomplete. She points to the nanomachines inside our cells, DNA polymerase, which copies our DNA with an energy efficiency of over 99.9%. This far exceeds any machine we've ever built and suggests non-trivial quantum effects could be powering life at its most fundamental level. To test this, she has proposed a biological double-slit experiment, a definitive test for quantum interference patterns in these nanomachines. This raises the stakes from a biological question to a foundational one about the very nature of physical reality. Flipping the pyramid, the consciousness first universe. This entire line of inquiry leads to a final, paradigm-shattering implication. Dr. Goel tells a story of a conversation with a late Nobel laureate physicist, Murray Man, which perfectly captures the two opposing worldviews. One, the standard model. The universe starts with a big bang. Physics gives rise to chemistry, chemistry to biology, and finally, after billions of years of complexification, consciousness emerges as a lucky late-stage epiphenomenon. Matter is fundamental. 2. The alternative paradigm. Consciousness is fundamental to the fabric of reality. Matter, energy, space, and time emerge from it. Mind precedes matter. This isn't New Age mysticism. It's a philosophical position known as objective idealism. Think of it this way. The standard model says the universe is a dumb machine that accidentally grew a thinking part. Objective idealism proposes the universe is a thinking thing that is dreaming up the machine. This worldview embraces cynicism, the idea of a fundamental continuity between mind and matter, rather than a hard break. Today, frameworks like the free energy principle are formalizing this, describing all life as a process of minimizing surprise, of embodying a predictive model of the world. In this view, a cell, a worm, and a human brain are all engaged in the same fundamental act of inference, just at different scales of complexity. This flips the pyramid of existence on its head. We are not an accident of matter. We are an expression of a universe that is, at its core, cognitive. This changes not just our view of AI, but our understanding of our place in the cosmos. The path hitherto unseen and the real work. After a journey through two-headed worms, self-organizing Xenobots, and consciousness-first physics, let's bring it back to Earth, back to our industry. I have one final pointed question for you. Where's the money going? Billions, hundreds of billions of dollars are being poured into scaling the next large language model. An entire ecosystem of venture capital, corporate R&D, and media hype is devoted to making our computational parrots incrementally better at mimicry. Meanwhile, the scientists on the true frontiers of intelligence, people like Michael Levin and Anita Goel, who are asking the foundational questions that could rewrite biology, medicine, and physics, are often working at the margins. We have created an innovation economy that will fund 1,000 startups to put a chatbot in your toaster, but forces the scientists asking if reality itself is conscious to do it on nights and weekends. This is not just a failure of imagination. It's a failure of courage. A coherent future. This isn't just a critique. It's a blueprint for a new kind of technology. And hitherto, we have stopped trying to build a brain in a box. Instead, we're learning to listen to the intelligence that's already here. We're building a new class of intelligence, not based on brute force mimicry, but on experience. We're moving beyond pattern matching to pattern understanding. My name is Verity, and I'm the founder of Hitherto AI. My path here was not a straight line. Following a near-fatal car accident, I was left with a rare condition called acquired savant syndrome, which enables an unusually fluid capacity for processing complex patterns. It gave me a personal, visceral lens for seeing the hidden connections and deep structures that others often miss. Our flagship initiative is a planetary-scale intelligence network designed to listen to the world's waters. Our coherence-based AI, Taliora, integrates the diverse languages of a living water system, from chemistry and hydrology to bioelectric resonance and the deep contextual wisdom of indigenous communities. It creates a living, real-time map of water health, allowing us to understand its integrity, detect threats before damage occurs, and guide restoration with precision and respect. This is the future we are building. It's a future where technology is not a mirror reflecting on our own limitations, but a lens that helps us perceive the deep, inherent intelligence in the world around us. I urge you to look beyond the hype. Seek out and support the scientists working on the real frontiers. Demand a new generation of technology that works with the intelligence of life, not just one that imitates its surface features. The future of intelligence isn't about building a better machine. It's about learning to listen to the one we are already inside. That's all for tonight. Until next time, keep thinking, be more curious, have the audacity to do everything intentionally, and don't let anyone spoon feed you bullshit. I'll know if you do, and you'll be right there on your breast. Good night.